In this brief lecture, we will look at how to analyze a practical electrochemical double layer capacitor. We would make this assumption that the capacitance of a double layer is assumed to be a constant. That is, it is independent of voltage. Is this assumption reasonable? If you go back and look at the various models which we have analyzed, that is the Helmholtz model, the Goy-Chapman model, and the Stern model, we do have a scenario wherein this is possible. To understand this, we have to look at two features. One is that when capacitors are in series, the electrode with lower capacity will dominate. Okay, so whenever you have such a scenario, which we do have in some cases, we have already looked at such a scenario within the Stern model. This is not an unreasonable assumption. What is important to understand is that the electrochemical double layer capacitors have two electrodes, and each electrode will have its own capacity, and the electrode with the lower capacity will tend to dominate. So when you have the capacitance of a device, the capacity of two electrodes will be added in this manner because these two electrodes are in series. And typically what is done is that both the electrodes are made up of the same material. So the analysis becomes simple. That it's a common design which is used in capacitors. This symmetric, these are called symmetric capacitors. So both the electrodes are made up of the same material. Another important feature of practical capacitors is that they are made up of very high surface area material. So typically carbon is used in many cases. The presence of high surface area enables increase in the electrode electrolyte interface and hence increase in electrochemical double layer capacitance. This is an important feature. So there is a great thrust on how to create high surface areas. Either you increase the porosity or you use nanoparticles and so on. This is a current theme of research. In the we are not going to elaborate more on the material aspects of these issues because they're they don't fall within the scope of this course. In this course, we typically look at the thermodynamics, kinetics, and transport aspects of electrochemical engineering and electrochemical devices. The material aspects are not unraveled in this course. So in the next lecture, we will look at another important topic, which is the IV characteristic of capacitors. Thank you.